and that is the import into existing tables. In this case, for example, you've got a table that might have either one table, a partition, or subpartition. When we import, because writers block writers, any worker or PX process that's importing has to take a lock on that table, partition, or subpartition into which it is importing. So if we know or can trust your partitioning scheme on the target side, in other words, if we know that the target database with its existing table has exactly the same partitioning scheme as the dump file or database from which we're importing, then we can go full parallel. Everything's fine. However, if for some reason we don't know that your existing table has the same partitioning scheme, then we have to play it safe and we import serially with one process at a time, no matter how many partitions you have, no matter how large those partitions are. The reason we do that is that if you had multiple workers trying to write into the same partition at the same time, you would have all kinds of locking and contention, and that can have other effects far beyond slowing down that one table. So let's talk about the specific case of table exists action equals truncate. So in this case, let's say you have a table in your target system, let's call it your development system, and you're doing a data refresh from production. Typical thing you might do there is just say, I don't want to regenerate my tables. Maybe you've actually changed something about the table, such as adding compression, adding encryption, doing something like that. And so you don't want to just regenerate the table as it was in the dump file, which doesn't have encryption or compression. You want to just import the data. So you say table exists action equals truncate. Well, what happens here? In this case, what happens is you'll see that we are importing serially, even though, because we have metrics equals y, you can see which worker process is doing which and how long each partition takes. You can see that worker 1 did one partition, worker 9 did the next one. You can see that it took 7 seconds, but because we specified log time equals all, we can see from the timestamp that the 7 seconds for the second partition comes in 7 seconds after the first one. In other words, it is not being done in parallel. This is why, by the way, that we always ask that you specify metrics equals yes, log time equal all when you have any sort of issue and you want it diagnosed. We can tell things like, did it go parallel in this case? Now let's contrast that to what happens when you do a table exists action equals replace. Because when you replace, what's happening is your existing table gets dropped and we use the create table DDL from your dump file or your source database to create the new table. And in that case, we know exactly what the partitioning scheme is, and we know that it matches the structure of the table in your dump file. So in this case, using the same table definition on the target and in the source, and then saying that we're going to replace that table in the target, what we see is that the partition took that exact same 7 seconds to import, but you see that it was less than 10 microseconds or about 15 microseconds after the previous one completed. In other words, they were happening at the same time, essentially. You're getting full parallelism because Data Pump knows that we created the table, we know that the partitioning scheme matches, and there will not be a locking contention issue. But as I mentioned earlier, sometimes you don't want us to replace that table. Sometimes you want to keep that new table definition and just refresh the data. So, well, what do? Are you stuck with a serial import and lousy performance? Well, not really, because we have provided since 12.2 this option, data options equals trust existing table partitions, exactly for this case. And we'll go back to the truncate case. So you're keeping your table definition on the target. Let's again say maybe you've added compression there, but you haven't changed the partitioning scheme at all. And you say data options equals trust existing table partitions. Here you see, well, for whatever reason, everything took longer. This was running in a VM, so you don't know what else was happening on my system at the time. But the 11 seconds that partition took to import was done less than half a second after the previous partition. So again, we can tell that everything was happening in parallel here. So data options equals trust existing table partitions is a terrific tool when you're moving to a new environment where you know that you have the same partitioning scheme, but you might have to change or might want to change other aspects of your table definition. Now, that's if we can trust you, because saying data options equals trust existing table partitions is like you holding up your hand and saying, I promise, Mr. Data Pump, the partitioning scheme in my target database is the same as in the dump file. But what if you are not telling the truth? Or maybe you just don't know. Maybe you thought it was correct and there was some difference there. Well, in that case, what will happen is we will detect that and we will give you an error. And the error says that the specified partition doesn't exist. Because what you've said is, I have partitioning scheme X, but in the dump file, we're seeing partitioning scheme Y. So to us, those are different partitions, and we can't load a partition that doesn't exist.